Welcome to STEM Lab, where we discuss preparing students for success in a rapidly changing world. And here's your host, Michael Newsome.
Happy to have you here with us today on STEM Lab. Our guest is Dr. Kemper Talley. Kemper is a senior scientist at Raytheon BBN, and he is an alum of the South Carolina Governor's School for Science and Mathematics. He has a Ph.D. in energy science engineering. At Raytheon, he works in the area of synthetic biology. He focuses on biodefense and security. So he deals with bioethics issues, augmented reality, and emerging AI threats. Before going to Raytheon, he worked at Teledyne Technologies, and there he developed numerous radiation detection products. But if all this is not enough, he's also into swing dancing. He and his wife, who is also a South Carolina Governor's School for Science and Mathematics alum, are involved in competitions, and they teach dance. So he's so accomplished. The reason I had him on the show today, though, is he is passionate about STEM education. Let's see what he had to say. Hello, Dr. Talley. Thank you for joining us today.
Hey, it's nice to join you. I really appreciate it.
Now, you are so accomplished. You have true interdisciplinary experience across several advanced STEM disciplines. I could easily ask you questions and make an entire episode about what the state of the art is in any one of these fields, like augmented reality, AI, synthetic biology, radiation detection. But I want to delve into something I know is a passion of yours, and that's STEM education. So let's start with a scenario question. If you had a magic wand and could increase the amount of and quality of one type of learning in high school today, what would you choose?
Well, I would probably choose physics-based education, not necessarily physics itself, but the strong mathematics that comes with physics and just the ability for students to be able to think critically about the underlying science and reason for why things happen. I think physics does this uniquely. That's not to say that other sciences don't do this, because they absolutely do. But physics is the one thing that trains people to think kind of about the first causes and why a certain phenomenon happens. And it's less about understanding properties of emergent qualities that might happen, say in chemistry. It's very difficult to understand the fundamentals of that aspect without understanding things like quantum mechanics, which really come much later in a student's understanding. Whereas kinetics and kinematics, those things are accessible even with very basic mathematics and help people understand things like momentum. Why does an object move? The very basic questions that Aristotle even asked thousands of years ago. And physics is really a discipline that allows people to ask those early and first questions. And that understanding is critical for basically everything that we do in science.
Now, I'm really curious because physics is thought of as very difficult. It's one of those last classes many students want to take. So would you see different levels of physics so that we could get, a level that would be appropriate for everyone?
And physics is a difficult class for a lot of people, but usually what I find when people express difficulty with physics, I ask them, did they like physics? And usually they say no, or they hated physics. And it's the next question I ask is, well, did you like your teacher? Or did you like your learning environment? And the learning environment is really core to understanding and gaining an appreciation for physics. And oftentimes people say it's difficult because it's just so mathematics focused. And so we start with the equations rather than with the understanding. We don't do the labs, the experiments where you can place a ruler on the side of a table, and if you hit it, it's going to fly off, and then put a sheet of newspaper over it, and then as soon as you smack that ruler again, it's going to snap in half, right? But because all of the pressure from the air is actually pressing down on that paper, there's an inertia there that you have to overcome. And what I find is that students think of momentum as, mass times velocity rather than the power of a body to move or the power of a body that it takes to stop something. And so when people think about things more in terms of the physical objects and the world around them, gravity not as negative mg, but gravity as the property of objects, like because of masses around them and the gravitational pull between objects. When people think about things in terms of relationships of objects, we tend to get a better understanding of physics.
Now, you mentioned the importance of teachers. So I'm going to ask you, did you know that you were interested in physics in that world from a very young age? Or was there a teacher or a group of teachers that made a difference in your life?
So I was interested in mathematics early on, and I always enjoyed mathematics and seemed to excel at it. And I had teachers who came along and nurtured that understanding. Um, and I was very fortunate there, but I really didn't know what physics was until I got to like physical sciences and my ninth grade course. And I had a professor Dr. Carmichael at Easley High School who was very instrumental in fostering that creativity. We actually did like a periodic table. Like I was very interested in periodic trends. And how, as you go across the periodic table, there are a number of properties that seem to follow. It's like a roadmap. It's not just this fancy block structure, right? It actually gives you some insight into the material properties of things. So I actually looked at that as in the lab and was able to study things that weren't taught in the textbook. I was like, well, I wonder if like resistivity and heating of elements and materials was this way. And he allowed me to like get into the lab and actually test that. He's like, well, I don't know. Let's find out, right? Is bismuth really going to heat up? And it really did. And it was quite hot to the touch. And so that nurtured my understanding and desire to know more about the physical world. And then when I came to the governor's school, I had Dr. Godwin, who was a phenomenal teacher. And I say this to everyone, I failed my first physics test because I really thought I knew what I was doing. And I was so focused on, again, the mathematics, and I relied on my equation sense and my calculation capabilities. But when it came to physics, the way that Dr. Godwin was teaching it, it's really about understanding the underlying qualities. If you do take a ring of a metal and you heat it up, what happens to the size of the hole in the middle, right? And you can go and calculate that, or you can just think about it. And it turns out thinking about it was the problem that I had. And that's what really captured my interest with physics, is that, I failed that first physics test, but then I learned to think about the problems differently and wound up doing very well in the class and pursuing it even in my senior year with quantum mechanics and in physics independent study on thermo. And then making a career out of it because someone fostered my curiosity in the world rather than saying, oh, well, you just got to calculate this number.
Yeah, I really like that answer, because what you're saying is you've got the mathematics, the theory behind it, but how it interacts with the real world and also with your intuition of how that real world works. That's important in that thought process. The equations can take you so far, but in truly understanding it, you have to relate it to something.
And when we see that again and again, when we see with like artificial intelligence, large language models, and these things that start spitting out answers, like you can follow an equation, you can get a number at the end of the day, but does that number make sense? Right? Does the output make sense? Like there were many times in physics where I got a quantity and I'm like, but that doesn't make sense. And then I found out that I'd actually made an error, or I had flipped a sign somewhere, had a factor of 4 or 2 somewhere. But you can't do that just by looking at the number at the end of the day or by checking your work again. You have to have this kind of idea of, does that make sense? And that's what I would say is the most important skill for people to learn in physics.
Well, now I've got a different sort of scenario question for you, but let's say that you have a child. Let's make it a 16-year-old daughter, and she sincerely asks you, her dad, I want to have an exciting career in STEM. So I want to be on the cutting edge over the course of my career. So if she's 16 and she's right now, what would you suggest she study in college?
I'm going to push even against my physics answers normally, and I'm actually going to say probably biotechnologies and the microbiology experiences are really critical and important right now. I think that biotechnology is what's pushing the most right now. I think we're chasing that dream of personalized medicine, and the only way we're going to do that is with an understanding of the processes and microbiology, the human processes, the plant, understanding the cell. And that experience is really only gained in a lab. You can learn these things in the classroom too, but you need those skills in the laboratory, the experimental skills to again, appreciate and understand what's actually occurring. I would encourage them to take computer science classes as well to learn how to code, or at least to appreciate algorithmic thinking. It's not necessary that everyone be a great coder, but it is necessary that everyone understand the principles of computation. Because a lot of people say, well, this is just magically solved by machine learning and AI. And it turns out if you understand some of the underlying principles, you can actually avoid most of that mystification of the process. So I would say right now, biotechnology, computer sciences, I still would encourage people to take physics, but I would caution people if they want to say they want to have an exciting career. While my career is very exciting, and I think you can do that in physics, I think the path can sometimes be easier in other technologies because you're so immediately applicable. You don't have to fight hard to see the application of biotechnology. There are humans walking around. It's very easy to see the mRNA vaccines and all these platform technologies, chemotherapies, drugs. You know someone who's been impacted by medicine. And we are now at the point where I think we're going to see some very exciting changes over the next 10 to 20 years. And if I can be so bold, I actually think we'll see some human diseases just not an issue later in the next coming decades.
Your answer is spoken like a true interdisciplinarian, and I like that. So it goes back to the creativity and how to put these things together. And you work in very advanced fields. You work in areas for the Defense Department and things that you would not even be allowed to talk about here. And you work with very smart people. So you've seen things come together. So I'm curious, what would you say is that secret sauce of creativity? Where does that come from? And what have you seen to the biggest and best advances in your career?
I think it comes from always chasing the idea of trying not to be the smartest person in the room. And one of the things I quickly learned from my boss in industry, one of the first things he said to me was, you may be the smartest person in the room for nuclear physics. And, I'd be hard pressed to find a bunch of people to bring together for that. But you're not the smartest electrical engineer. Guess what? We have an electrical engineer on the team. You're not the best mechanical engineer. There's a mechanical engineer on the team. So having that deep expertise in my area and then understanding that other people have cultivated that over time. And it's not just STEM, right? When someone with business sense comes in and they talk about what the customer really needs, having that interface with those folks. So I think what it is interacting with people who don't know what you know. And you think about problems differently than you think about problems. That is what I think is core to the creativity and the success of those things. Is I do approach things like a physicist, but it's often very helpful to think like an engineer or a business developer. And when I think about those, whenever I'm in a room and let's say I'm surrounded by scientists, I try not to think like a scientist. When I'm in a room filled with engineers, I try not to think like an engineer, because who's not in the room? And I think that is often the perspective that we fail to take, is we get trapped in this little bubble, and we even make them, right? We make these special conferences and highly specialized subject areas, but we always have to step back. And usually creativity comes from the outside. And if we can place ourselves on the outside, I think that helps us a lot.
I think that ability to work with others, those soft skills, so to speak, but also understanding that it's a team effort, that comes with maturity. I'm always amazed when I find a young person who already understands that. What about you? Do you think you had that innate sense early on, or did you develop that later in your career?
I developed it. I tell people that I'm glad they didn't know me when I was younger, because I still have some personal qualities that I would always improving, right? And always want, but I think the biggest thing that I said that I hated group projects, right? And because I was carrying the weight of the team. And I find this happens with strong science and mathematics students all the time. They get in these group projects and they feel like they're always carrying the thing. And that's not how it really works in the professional world, for at least in my experience. And what often I had to learn was letting people do what they're good at, or finding what they're good at. Delegating in that way is like, if I'm really good at this one particular thing, let's say the mathematics of it, then I'm going to handle the calculation, but somebody else is better at writing the report. and just try to talk about this on the high school level of those things, like let that happen. If somebody's really good at editing, copy editing, or proofing, let that person be that second set of eyes. And no matter what, you need to be able to communicate your work with your other team members, even if they aren't as like strong in a particular technical skill, because you can't do everything. And I find myself, I find the most success when I rely on my teammates more, but rely on them in ways that they can handle. I wouldn't go to one of my friends who's a wonderful bioinformatician and say, I'd like you to talk at this conference in front of 500 people. It's just not something they're going to be comfortable with. So that's but I learned that through actually swing dance, is where I learned this, because I started interacting with folks who weren't all STEM. Like being at the governor's school was actually hard because we were just surrounded by a bunch of other folks like me. And so when I came to college, going to extracurricular activities in a graduate school, I pretty much danced outside of my technical time. And that's where I had to learn how to interact with people who didn't see the world the way I saw it, or even from a scientific lens. And that's really probably what taught me the most of how to work with other people.
Yeah, that well-roundedness is so important, and working in groups. And you see more and more of that type of process working its way into modern curricula. So we do a lot of project-based learning, a lot of teamwork, and we work really hard here at the Governor's School now on the whole student, make sure they participate in sports and other activities. So what do you think you learned in swing dancing that's applied to your career the most?
Probably what I learned is I had done music. I had the skills there for like rhythm, and so it wasn't the technical things. It was the asking someone how to dance, that you don't know them at all, and then having a conversation with them in that social dance, not even just talking, but just trying to meet with somebody on a physical human level. And then the song is over in 5 minutes and going and asking someone else to dance. Right. So throughout that entire night, you could dance with 20 to 30 different people, and every single person is different. Every single person's unique. If you come to that dance saying, well, it's me and I'm going to talk the whole time, or I'm going to bring my experience and my stuff and not going to listen to you at all, you're going to have a very bad social dance. And you're going to have you might have a night where you're like, oh, well, this person didn't really dance well with me, and this person didn't dance well with me. It's like, well, you were dancing with yourself all night. So it's really just the collaboration that I learned. And then when I started to teach swing dance, and everybody teaches before they're ready, and actually teaching taught me the most about how to communicate with others and try to understand things from the student's perspective. I have traveled a good bit in teaching as well, and that helps me a lot, because students in my area don't learn the same way that students in other areas learn. And it's because they've had different teachers. So taking that reset every time, in trying to understand, well, how did these students learn? How did these people connect with me? That's been the core, I think, skill that has helped me the most, is level setting with another person. Listen to the way they talk, listen to the way they express themselves, their body language. And I'm still I personally think very bad at reading people's body language. But it's something, it has gotten better over time, and it's by experiencing with more and more people, and across different cultures as well.
Yeah, that is so important. I know I've had the good fortune to be able to teach in India, to teach in China, South America, Europe, and have those students in the classroom. And it really makes you take a step back and look at what you're teaching. What are you really trying to accomplish? What's the important part? How do you get this knowledge across? I've got a different sort of question here, and I can't let you off the hook without asking you about AI. It's the hot topic right now. So is AI evil? Is it a panacea, or is it something in between? And if it's in between, what the heck should we be doing with it?
Yeah, well, I'm generally of the opinion that tools are neither evil nor good, and that the intentions behind them often belong to the people and how those tools are leveraged. Now, that doesn't mean that there's not a responsible use and a way to inculcate that and put that in law, put it in culture. And those discussions absolutely need to be had. But AI is certainly not a panacea for a lot of things that people want it to be. You see people replacing employees or stuff with AI, and those people are going to have problems very quickly. There are some things that can absolutely be replaced by AI, but you can't replace is a person. If you're replacing the person's time, guess what? That person now has more time to be creative in a different way. To me, AI is a productivity tool. It is, and that's how I use it. I use it to test ideas. Most of the folks that I know use it in some way or another, and it's to explore, to have a sounding board, to see, oh, I have this crazy idea. It's to have an outside perspective, sometimes to generate those ideas when you can't talk to another person. We've already seen an explosion capability. And it seems like every time you turn around, every 3 to 6 months, there's a new advancement. There's a new capability that we didn't have 3 to 6 months ago. People like to harp on the AIs for hallucinations and problems that it makes, like drawing humans with multiple fingers that are in the wrong places, or violins that have way too many strings. Okay, but does it happen again in a year when the model gets better? Or if you ask it a different question, like, no one faults a car for not being able to drive on water, right? And no one gets mad at animals or other tools and things around us in the world that don't fit in an environment. Not to say that animals are tools, right? But you don't bring a horse to the beach and hoping to like go across the water, right? AI is a tool. And it has appropriate places. It has inappropriate places to be used. Students are going to use it to cheat. That's just how it's going to go. But students have always found tools to use to cheat. All right. Is this a harder one to detect? It might be. And I think what's important here is, again, that physics-based understanding, or that real-world-based understanding. When the AI spits out something, how do you know it's true? Right? It's hard to know that sometimes. I won't say that I'm not worried about it, because there are things that I worry about in the AI space. But I think if we just try to lock things down, we throw away the whole thing, right? And there's so much good that comes with this technology as well, that we should be prepared to learn how to use it wisely, to create a better future rather than a more dystopian one.
Well, let me, I guess, narrow that down just a little bit. When you think about AI and education, you mentioned that students can cheat with it, but you also mentioned how it can open up a lot of different possibilities. So what do you see the future of education looking like? How is it changing? If you could project maybe 10 years down the road, how is it going to look different than it looks today?
Well, I'm reminded that the folks who often make predictions are very often wrong. But so I'll make some general claims, and then I'll make some specific claims. And general claims, what I see going forward is that the tool will be used, and it actually will be a learning tool going forward. Khan Academy is already starting to use this tool to enable things to write like new equation sets, new problem sets, right? Write a new word problem. It is one of the best word problem generators that you could possibly hope for in some of these ways, right? It can generate different problems for students to work through. So in a way, if the student is ever struggling with an aspect and you've run out of worksheets, right? These capabilities are going to be able to endlessly generate problems for students to hone their skills. And I do think that will happen. I think one of the things that will happen is, I think about this all the time, is like true false is one of the hardest problems sometimes. This is a great true false generator, right? If you have to ask the question, is this statement true or is it false? And if it is false, why? And these tools are great for that. AI will probably make the writing process easier for some folks. Now, I have a good friend who's an editor and is exploring the uses of AI in the space. And I do think that we're going to see changes there as well. And of course, that is a major part of a student's learning. It's how do I write? How do I learn to express ideas? So that's the general things. I think it will help us with kind of the tools of writing. I think it will help us with kind of practice of problems. I think people will cheat with it more, and I think it will be harder and harder to detect. And the only way that basically you can prevent that is you'll see some tests and exams that are closed off entirely to technology. I think those are good things because people need to learn how to think without a tool. And yeah, so now I'll go into kind of the specifics that I hope to see in the next 10 years. I think students should be able to solve problems faster. And I think that if they misunderstand something from a textbook, then they have a different way of having interpreted to them. They put in that text and say, explain it to me like I'm 5. Okay, explain it to me like I'm an astrophysicist. Explain it to me like I'm talking to my mother, or I'm talking to an alien from a different culture, right? The way that the capability that it has to basically regenerate the text or find a way to express it differently. That, I think, is one of the ways that in the next 10 years we'll be able to reach more students with more, whatever you want to call the learning styles or whatever they might be. But people have their preferences, and I think that AI will enable those preferences to be more easily met. For students with audio problems, learning disabilities, I think that these tools are going to be incredible for helping students with learning disabilities. We just have to learn how to use them. So that's where I specifically hope that technology will help people. I'm already starting to see that with Khan Academy. And as far as a misuse, well, I do think that some of our skills will atrophy. I think that if you take people away from a keyboard, from some of those things, I think people have harder times writing or expressing themselves if they don't train it. So I think we'll see kind of a bifurcation of people who learn how to use the tools very well and appreciate and respect the tools, and then people who kind of just use things blindly. We already have that, right? I just think it's going to get more pronounced.
So you can see AI as being more individualized attention on students. And so the role of the teacher will change over time. And that kind of leads me to my last question for you. And that is advice for STEM teachers and administrators in those disciplines. Given the way the world is changing, given what you know about what you needed in your career and how you developed, what advice would you give those STEM teachers and administrators?
My first thing that I'll tell people is don't be afraid of the technology. These things have come and gone in human understanding in the past, right? The calculator, the printing press, we've always had teachers, we've always had students. This mentor relationship is core to our growth as individuals, as a society, and even as a species, right? So foster those relationships so that when people do have problems with these technologies, they want to come to you with their problems, and test these tools out. Your students are using them. You might as well know how they're going to use them. Be creative, intricate, right? Well, one of my favorite things to do is break the tool, find out where it doesn't work, and then ask your students those questions, right? And find out where the tools are insufficient. And now you've got something that can give you those surface level details very quickly. So guess what? That means that learning can hopefully happen faster. And if it does with those students, you can challenge them to go deeper. And I think if students can learn these things individually and the teacher has more time, then crafting those experiences for the students, right? I was very fortunate in my education to have people who helped me specifically. My math teachers that I was talking about pulled me aside and said, hey, everybody else is doing this worksheet. Why don't you do this one? Right. Or within the physics environments, I think you'd be good at this problem, right? Or this invitation to students to say, Well, let's take it to the next level. Students can get bored easily, and I think this technology can help maybe with the students that get bored. So don't be afraid of it. Use it, and at the same time, force your students to not use it as well. We need to be able to work without it, but everyone's going to be using these kind of productivity tools going forward. Then that's just the nature of it. So.
Well, thank you so much, Dr. Talley. I really did enjoy the conversation today. You made me think about a lot of new things.
Well, thank you so much. I really enjoyed it as well, Michael, and I'm always happy to talk about those things. And if people want to reach out, I'm happy to talk as well. Folks can find me on LinkedIn or reach out to you for information. If your students are looking for ways to get plugged in, I really do recommend the Governor School and other science education camps around. And if you're looking for other places to get plugged in, reach out, because there's a lot of us who could use new, bright young students coming up and learning these skills.
I really enjoyed the conversation with Kemper today. He showed so much insight, and he got to the core of issues, no matter how complicated and how many issues we talked about. And that's really at the core of his own education theory. The students need to understand the applications of the theory, and they need to have an intuitive understanding of what they're learning. He also talked about teamwork and how important it is to be able to communicate with all of the different members of a team. Well, I hope you enjoyed today's interview, and remember, until next time, keep learning and growing.
You have been listening to STEM Lab, produced in the studios of the South Carolina Governor's School for Science and Mathematics.